Hi there. This is going to be a quick video on how to use scriptable objects in Unity Engine to store logic and relationships between objects that actually have assets behind them. So this is kind of in the whole realm of talking about converting between using nothing but mono behaviors and nothing but in-scene references to taking what makes sense to convert into using scriptable objects to perform those tasks that can remain kind of autonomous. So in a previous video, I talked about and showed an example also about changing the type of a ball in this case to match the type of maybe a pad or a gate on the walls. So in this example, we have when the ball comes in contact with the pad, it changes the material of the ball. So that previous example, I added some materials to this, but it was essentially the same um, the same example here. So what I'm going to show is how to have a little bit more configurable logic. So that's really just what the main benefit is in using a scriptable object as a system, is that you can have logic or configuration or settings outside of the scene or outside of the scripts that are within your mono behaviors, that you can switch or create new different configurations and have those be available within the editor for designer to actually configure and set up without having to write additional code. So that was, again, a benefit of having scriptable objects as enums or types, because the designer or game creator within the Unity engine doesn't need to add code to add another type. So this is an example of the system. You set the system and you have that configuration and the logic that is coded, and then the designer can then use those systems, kind of like the same situation with the enums. So the end goal of this is to change the functionality of this example to where the ball will change colors based on what its color is and the gate's color is. And so and will allow the designer to decide based on creating multiple systems if they want to change that logic. So the first thing I'll do is just go over the basic scripts that I already have. So this is the ball behavior, and it has a reference to a ball type, a renderer. It's got a property here that when the ball type is changed, then it calls set type, which changes the material. The ball type itself is just a scriptable object. This is the example of a scriptable object as an enum, but we've created a separate one that just has some properties, some special properties, and that's this ball material is the only property that defines that type. So again, when the gate comes into collision with that ball, then we are just setting the ball type to that conversion type. So this is the gate type essentially, and then this property change, this ball type property change, is what's calling the set type and changing the material. So that's how the example currently works. And so what we're going to do first is create a new ball system script. And this is again going to be just a scriptable object. It's going to be very similar to the ball type. Except, and we're going to have this create asset menu as well. Let's add that in there and change this so we can create more than one if we want. And so the ball system is going to store for us, first of all, a ball type that's the default ball type. So I want, at the very beginning, I want this the ball to be initialized to being a certain ball type. So right now it's just blank until it hits a wall, and then it changes its material. But I want at the beginning of the game for that to be set to a specific ball type. So the reason I want to show that is because we're going to be using a singleton to have a reference to our system. So again, going a little bit further into why you would do that, like why would you use scriptable logic versus a singleton mono behavior that has all of your logic in it? Well, if you have it in a scriptable object, then again you can have multiple different configurations, and then that reference, you would store a single reference to that current configuration within the game. So we're actually going to use both. We're going to use a singleton game manager script, and then we're also going to use give it a ball system reference. So the other thing we need in the ball system is just keeping track of the conversions. So this is our logic. So this is the custom logic that you would add into the system. So for this, I'm going to need a class, and we're going to call it ball conversion, and we're going to just give it 3 ball types: input type, gate type, and an output type. And we're going to give that a serializable tag there so that it comes into the editor. And then this is just going to have a list of those ball conversion. Okay. So, and the logic that we're going to do can be in this scriptable object itself, or we can put the I'm sorry, this needs to be public, or we can put the logic in the actual gate. So I like to put all of the logic of what's going on. I mean, again, this is the benefit of having the system do the work, is that your logic is kind of separated into the system. So I'm going to add a public a method here. Actually, it's going to return a ball type called check conversion, and it's going to take input type and a gate type. Okay, so the first thing we're going to do is search our conversions. Find, I'm going to use a lambda expression here, so find a conversion such that conversion dot input type is equal to the input type. So sorry, that's a little bit confusing. I'm going to rename this to just input and gate, just to be clear. So I want the input type is equal to input, and the conversion dot gate type is equal to gate. And if the conversion is not null, then we are going to return the conversion dot output type. Otherwise, we're just going to return the input, whatever you gave it. All right. So actually, I'm thinking ahead of time here. We want to know whether or not the conversion actually exists. So if we just return the input, then we're not going to know whether or not the conversion was done. So the functionality that would happen then is if it hits the wall, if it doesn't get converted, it's still going to bounce back. The force is going to still be applied. So I'm actually going to return null here if the conversion can't be found, or if the conversion is null, excuse me. Okay, so that's the system, and that's our special logic. Now we just need to add the game manager that will store a reference to this system. So for that, I'm just going to create a new script, and this is going to be our singleton that will, it's going to store a reference to that, or really to any ball system asset. So open that guy up, and we're going to add a static game manager named instance, and technically you would do your singleton here checks, so you would check if an instance already exists of game manager and delete it, but I'm just going to do this. And so that's that, and then we'll add our system reference in here. So this is literally just making it so that any script within the system or within the code can access this system. You could also do that kind of here. I guess that's the only kind of thing. You've got a separation between between the mono behaviors and the scriptable objects. So there's no start, or update functions in these. So you really do need to have some kind of in-game object that is able to store these or to handle this. So we'll see how that works here in a second. So I'm just going to create a new game manager object and add that script to that. And so we just now need a new ball system. So I'm going to go to create scriptable objects ball system. And we'll add the reference to that. So one thing to note here is that because this initialization is done in start, this instance is being set here. It might be obvious, you might be already realizing at this point. We also have some issue. We will run into issues if anything else is done in start that is trying to grab this. So what I'm going to do is add a default execution order of -100 to this class, so that to make sure that this instance is set before any other script grabs it. So that's actually exactly what I'm going to do here, because remember we want the ball to initially be set to the default behavior, the default type, the default ball type of the system. So I'm going to add a line here into the initialization of the ball behavior that's going to set the ball type to the game manager .instance .ball system .default ball type. So that is going to obviously call this property, which is going to set the type, which is going to change the material. Okay, so that's going to initialize, and on the new ball system, I'm just going to set that default ball type to one of my types. We'll set it to the green one. So now technically we should get a green ball at the beginning here. Yep. So that's working. We've got our initialization, but our default behavior is still going on. So the default behavior is coded into the collision, obviously, of the gates. So let's go ahead and manage that. So in the collision of the gate behavior, we've got all we're doing is converting it into the gates type. So I'm actually going to change this to gate type just to be a little bit more consistent. So what I'm going to do here, instead of just changing it to the gate type, I'm going to use the singleton reference again. So that's why it's good to have it in a singleton. I mean, you could store in the gate behavior reference to the ball system, which is totally okay, but then again, you would have to in your code or in your reference on every single gate, you would have to add that reference to the ball system. So it's not a big deal. It's kind of up to you how you want to store that reference. But again, it's really easy to just store it in a singleton if there's only one reference to the system, that is. So yeah, so instead of changing the ball type here, uh, we are just going to use that function that's in the system of check conversion. So when we get a collision, we want to call this function, giving it the ball's type and the gate's type, and if it's non-null, then we're going to set it and do the little physics thing. So we're going to say new type is equal to game manager, dot ball system, instance dot ball system dot check conversion. And we've got a reference to the ball already, so we just want to do ball dot ball type, and then the gate type. Okay, so that should be that for this. So if this is non-null, then we want to do the adding of the force, but we also want to set our ball type to the new type. So again, this logic is really it really knows nothing about what's going on in this function. So that's why, again, in adding all of your logic in here allows you to control that relationship. So this is going to convert whatever this outputs to. So now we're ready to test the system. We've got 3 gates, and each one of them has a reference to a scriptable object that represents their type. And we have the player object, which has a ball behavior script that has a reference to its own type function to change the material based on that type's material, and also initializes itself to the default type that's on the ball system. And our ball system has a default ball type of that type. So again, it will initialize to that initial type, but it won't actually do anything. So we get a green ball at the beginning, but obviously we don't see anything here. So this is where the magic of the scriptable logic system actually happens. So we can change this system at runtime. We can, because it's an asset. These things are assets, so it's a powerful thing, but also obviously dangerous thing if you make changes and tweak things while it's running, but you expect them to be undone. But again, that's really the benefit of these. One of the benefits of these assets, that you can make multiple of them and have different configurations. So I'm actually going to add a conversion here at runtime. I'm going to say that if the ball type is green and the gate type is red, then I want to change it to purple. So now when I hit the red gate, it'll change to purple. And we do get the physics of knocking it back. So obviously there is no conversion between purple and red. So, but I can add one. So I'll just add another one. So I say if the ball is purple and the gate is red, I'm going to change it to green. So now we get that function. So now it'll change from back and forth between the two. And so obviously there's no conversion from green to green, and there's no conversion from green and purple. So this is the power of that you're putting into the designer's hands. They can not only go in and create new ball types and associate new materials with them, but now they can also come in and add the conversions between those types, all without doing any code. So I hope that makes a lot of sense. And if you got any questions, let me know. And appreciate the comments and feedback. Thanks.